All right, we're moving on to lesson 1.7, evaluating expressions. And actually, that is not correct. We are going to be working with functions. So, we're going to start off with some vocabulary. A relation is, as it says, a relationship between sets of values. In math, the relation is between the x values and the y values. So a relationship between x and y values. A function is a relation, but every x has one y. Another word for x and for y is input and output. You can go ahead and write those notes in. Input and output. You'll hear me say that a lot. Domain is another word for the x value or the input. Range is another word for the y value and the output. An independent variable does not depend, whereas dependent does depend on another value. The domain, the x value, is always going to be our independent variable. That's the value that usually gets plugged in. Whereas our y value is going to be our dependent variable that is going to depend on what the x value is. So there are several different ways to represent relations and functions. We have a table, we have an ordered pair, we have a mapping diagram, and we have graphs. So let's say we are working with the ordered pair 1, 2, 3, 4, and 5, 6. That is the ordered pair that we're working with. My inputs are 1, 3, and 5 because those are the x values of my coordinates. My outputs are 2, 4, and 6 because those are my y values. So my x's slash inputs in this case are 1, 3, and 5, and my y's slash outputs are 2, 4, and 6. Basically what this is saying is that when 1 goes through a function, it spits out 2. When 3 goes through that same function, it spits out 4. 5 spits out 6, etc. So then we can also write this as a table. 1 is the input, and we had 2 as an output for that first set. 3 is an input, 4 is the output for the second set. 5 is the input, and 6 is the output for that third. We also can do them as mapping diagrams. So we can do our inputs on this side and our outputs on this side. Our inputs were 1, 3, and 5, and our outputs were 2, 4, and 6. We simply draw our lines. 1 goes to 2, 3 goes to 4, 5 goes to 6. The last way we can represent a function or relation is by graphing. We can graph just as we would any set of ordered pairs. So we start with 1, 2. Our x is 1 and our y is 2. We plot our point. And then we have 3, 4. Our x is 3 and our y is 4. And then we have 5, 6. 5 up to 6. Those are all of the different ways that we can represent functions and relations. One of the most important parts of this unit is determining When a relation is a function. When is a relation a function? A relation is a function when every input has one output. So if an input has two outputs, it would not be a function. A good example to go off of, let's go ahead and look at letter B. Our inputs are as listed: -2, 1, 3, and 4.5. -2 goes to 1. Okay, so -2 goes to one output. 1 goes to 2, so 1 goes to just one output. 3 goes to 3. This input goes to one output. But then we have 4.5 goes to 4 and to 5. This input has two outputs here, the 4 and the 5. Therefore, making this one not a function. Letter B is not a function. And we will go through many more examples of these in class.